Good afternoon. I'm going to do a simulated lesson. There's no class here. I'll try to recreate something that I did towards the end of an Algebra 1 class. Sorry, I'm dressed for mountain biking and got a lot of things going on this summer, so I'm just trying to squeeze this in. So without further ado, the lesson today is going to be relating completing the square to the quadratic formula. All right, so completing the square is a process that we follow, and we can use that to solve any quadratic equation. Some of them would be much more complicated than others, depending on whether a certain term is even or odd. And then the quadratic formula, which is one of those formulas that you can then memorize. You don't really have to know why it works or how it works, but it will work also for solving any quadratic equation. So I'd like to just show you the relationship between the two. It's a little bit beyond Algebra 1, all right? It's going to probably push some people outside their comfort zone as far as working with only letters, right? Not a lot of numbers going on. So mostly letters, I should say. But let's get started. So first I'd like to review the completing the square process, okay? And I'm going to start that by giving you a quadratic equation that cannot be easily factored, okay? And so, so I said a quadratic equation, all right? So it has an equal sign, okay? It's a quadratic because the highest variable term is squared. And so we know that the standard form for a quadratic equation is ax squared plus bx plus c equals 0. So this is a quadratic equation that is in standard form. And normally, factoring, we would look for factors of 2 that add up to positive 8. And so clearly, this is not something that can be factored. So we're going to resort to completing the square, which we've been working on quite extensively. All right. So remember, the first step in completing the square is, right, and I would wait for a response. Maybe they would say subtract the constant. Maybe they would say take half of this and square it. I would sort of direct them towards a standard process, which would be subtracting the constant. So yeah, that's correct. We're going to subtract the constant, right? We'll bring our constant term to the other side. And remember, we're going to rewrite at every step. We want to rewrite the equation in its entirety. All right, but when we rewrite it, we're going to leave a little space there, all right, because we're going to be filling that space in now in the second step. All right, so now how do I actually go about completing the square? How do I turn this side of the equation into a perfect square, right? And so I'd wait for a response, and it would be yes. I take my b term, which is 8, and divide it by 2, right? b over 2 squared. All right, and so that's going to be 4 squared, which is 16. And now I'm going to add 16 to both sides. Okay? And I know it's a little bit to do, but we're going to rewrite it at every step. All right, and 16 minus 2 is 14. Okay? So now we have completed the square, okay? And so this is called what? That quadratic is called what? Hopefully I get the response. That's a perfect square. So yes, it's a perfect square, which means it factors down to, right, the square root of this term, right, the square root of that term, right, and then the sine of the b term, right, and then we take that and make that quantity squared, right? And that's going to equal 14. And so now we have it in our factored perfect square format, and this was the key, right? The square is no longer attached directly to that x variable. The square is outside the parentheses, so now I can access that x variable. I can solve for that x variable. And that's what we're always trying to do, is to solve for the variable, right? That's one of the basic principles in algebra. So now I can take the square root of both sides, right, which would be our next step. I I might be asking for this rather than actually dictating it. And when I take the square root of this side, remember, I have to consider both the positive and the negative square root. So what I wind up with is, right, the square root of the left side equal to the positive or the negative, the square root of the right-hand side. That's how I get my two solutions. That's how I get my two roots, my two solutions to this equation. And so now it just becomes a simple subtraction problem. I'll bring the 4 over to the other side, and I wind up with minus 4 minus 4. I wind up with x equals negative 4 plus or minus the square root of 14. Okay, so there are my two solutions, my two roots to that problem. I'm going to stop the video for a second.